On the afternoon of May 25, 2002, Taiwan's Taiwan International Airport was operating normally as passengers boarded China Airlines Flight 611 for its scheduled journey to Hong Kong. Business travelers settled into their seats, families prepared for the short regional flight, and the Boeing 747-200 completed its routine departure procedures before taking off over the Taiwan Strait. The aircraft had been in service for more than 2 decades and had flown thousands of successful flights throughout Asia. Nothing during the departure suggested that just minutes later, the aircraft would suffer a catastrophic mid-air breakup, resulting in one of the deadliest aviation accidents in Taiwan's history. The Boeing 747-200 that operated China Airlines Flight 611 on May 25, 2002 had been in service for more than 2 decades. It had been delivered to China Airlines in 1979 and had spent its entire commercial life with the carrier. By 2002, it was the last Boeing 747-200 series aircraft remaining in China Airlines' passenger fleet, the others having been converted to freighters. The flight on May 25th was scheduled to be its last commercial passenger service before transfer to Orient Thai Airlines, a charter carrier based in Bangkok. The aircraft was operating a routine scheduled international service from Chiang Kai-shek International Airport in Taiwan, Taiwan, to Hong Kong International Airport, a short overwater crossing lasting roughly an hour. There were 206 passengers and 19 crew members on board, a total of 225 people. Most passengers were Taiwanese nationals connecting through Hong Kong to visit mainland China. The flight crew consisted of Captain Yi Xingfong, 51, First Officer Shi Yaxiong, 52, and Flight Engineer Xiao Senkao, 54. All three were experienced aviators with no recorded performance issues. However, to truly understand the tragedy of Flight 611, we need to go back over 22 years. On February 7, 1980. On that date, the same aircraft, then registered as B-1866, was operating as China Airlines Flight 009 on a route from Stockholm Arlanda Airport to Taiwan, with intermediate stops at King Abdulaziz International Airport in Jeddah and Kai Tak International Airport in Hong Kong. During the landing at Kai Tak, the aircraft's tail made contact with the runway, a tail strike. The lower aft fuselage section, specifically the aft lower lobe of the fuselage at Station 2100, was damaged. The aircraft was depressurized and ferried back to Taiwan the same day. A temporary repair was made the following day. A permanent repair was carried out by China Airlines engineering team from May 23 to May 26, 1980, over 4 days at the carrier's maintenance facility in Taiwan. The Boeing 747 Structural Repair Manual, or SRM, specified 2 acceptable methods for permanently repairing tail strike damage to fuselage skin. The first, to remove the damaged skin section entirely and replace it. The second, remove the damaged area by trimming it back to clean metal, then install a reinforcing doubler plate, a layer of structural material riveted over the repaired area to restore the skin's load-bearing capacity. In both cases, the purpose was the same: ensure that no damaged material remained in the structure, and that the repaired area was at least as strong as the original skin. The China Airlines team, however, did neither of these things correctly. The damaged skin was not removed. The scratches left by the tail strike, longitudinal marks running fore to aft across an area more than 2 meters long and half a meter wide, were sanded down but left in place in the fuselage skin. A doubler plate was then installed over the area. The doubler was too small. It did not extend far enough beyond the damaged area to contain it within the outermost row of the rivets securing the plate to the skin. Some of the scratch damage and the microscopic stress concentration associated with it lay outside the protective coverage of the doubler. The repair was lodged by China Airlines as having been carried out in accordance with Boeing's Structural Repair Manual, obviously. It was characterized internally as a minor repair, a classification that, as investigations would later note, was clearly incorrect for any repair affecting primary fuselage structure. No Boeing engineers ever reviewed the work, and there was no independent verification performed. The aircraft was simply returned to service. Each time a pressurized aircraft climbs to altitude, the cabin is pressurized to maintain a breathable environment for passengers and crew. Each time it descends and lands, the pressure equalizes with the outside air. This cycle, pressurization on climb, depressurization on descent, subjects the fuselage's skin to repeated stress. Over thousands of cycles, this stress causes microscopic cracks to initiate and grow in any area of the skin that contains a stress concentration. The process is called metal fatigue. It is well understood, and it is why aircraft maintenance programs include regular inspection of fuselage skin, with particular attention to areas that have been repaired or subjected to previous damage. Over thousands of cycles, this stress causes microscopic cracks to initiate and grow in an area of the skin that contains a stress concentration. This could be a scratch, a corrosion pit, or a fastener hole. At the edge of the undersized doubler plate on B-18255's aft fuselage, in the area between the plate's perimeter and the outer row of rivets where the tail strike scratches remained exposed, fatigue cracks began to form. They were invisible from outside the aircraft. The doubler plate simply covered them. In 1988, following the explosive decompression of an Aloha Airlines Boeing 737, which I'll be covering soon on the channel, over Hawaii, an accident caused by metal fatigue in an aging fuselage, aviation authorities worldwide mandated that airlines review the skin condition of older aircraft, including aging 747s. China Airlines conducted inspections. The fatigue cracks developing under the doubler on B-18255 were not detected. For 22 years, the aircraft simply flew. Each pressurization cycle put more stress to the skin. The cracks at the edge of the doubler grew longer. By the time of the final flight, the fatigue damage beneath the plate had reached a critical state, which the aircraft's maintenance history gave no indication of, because the cracks were hidden beneath a plate that had been installed over unrepaired damage and logged as a conforming repair. There was one additional circumstance that investigators later identified: the faying surface of the doubler plate. The surface facing fuselage skin beneath it showed fretting marks, regular space abrasion patterns caused by the crack growing beneath it, flexing against the underside of the plate during each pressurization cycle. These marks were present on the recovered plate. They indicated that the crack had been growing for a long time, and that, as it grew, the doubler plate had been acting as a concealment rather than a repair, hiding the advancing damage from any external visual inspection. The investigation also discovered that the maintenance record for the 1980 repair were incomplete or simply missing. China Airlines attributed this to inadequate record-keeping practices in the 1980s and records lost during office relocations. How convenient. Records that did exist did not accurately describe what had been done. One further detail was noted in the investigation. Photographs from maintenance records showed discoloration on the doubler surface in the affected area. This discoloration was later identified as tar staining from cigarette and cigar smoke. China Airlines had permitted smoking on its flight until 1995. Investigators noted that the discoloration had been investigated by maintenance personnel. It would have been prompted closer inspection of the underlying area, which would have revealed the cracking. However, the personnel never did any investigation, and they never found the crack. Back to May 25, 2002. Flight 611 departed Chiang Kai-shek International Airport at 15:07 local time. The takeoff and initial climb were normal. At 15:16, the crew checked in with Taipei Area Control and were cleared to climb to FL 350. And were cleared to climb to flight level 350, 35,000 feet, their cruising altitude for the short crossing to Hong Kong. The last routine radio contact with the crew was at 15:16. The conversation with Taipei ATC was entirely normal. Nothing in the CVR indicated any crew awareness of a developing problem. At 15:28, Taiwan's military radar observed the Boeing 747's radar return split into 4 separate returns. the signature of an aircraft breaking apart in mid-flight. Contact with the aircraft was lost simultaneously. The aircraft had been airborne for approximately 20 minutes and had been climbing through approximately 35,000 feet when the fuselage failed. The breakup sequence reconstructed from the radar data, the wreckage distribution, and the forensic analysis of recovered components was this. The fatigue crack in the aft lower fuselage reached a length at which the remaining skin could no longer sustain normal pressurization loads. The skin failed explosively. The rear section of the fuselage separated first, with the aft structure gone. The rest of the aircraft, now structurally compromised and subject to massive aerodynamic forces it was not designed to withstand, broke apart in seconds. The Boeing 747 disintegrated into 4 main sections, which fell separately into the Taiwan Strait. There was no distress calls, there was simply no time. All 225 people on board were killed. The wreckage came down in the Taiwan Strait, 23 nautical miles northeast of the Penghu Islands, in the water approximately 66 to 100 meters deep. Deep enough to complicate recovery, but shallow enough to make it achievable. Taiwan's Coast Guard and Navy deployed vessels to the area within hours. The recovery operation was conducted over several weeks, with the crews working in difficult sea conditions. The flight data recorder and cockpit voice recorder were both recovered. The CVR confirmed that nothing in the cockpit during the flight had indicated developing structural failure. The crew simply had no warning and no opportunity to respond. The physical recovery of the wreckage was critical to the investigation. Investigators needed to find and analyze the section of the fuselage that had failed first, the piece that had initiated the breakup. In a catastrophic in-flight disintegration, identifying the origin piece requires close examination of fracture surfaces. A piece that failed due to metal fatigue will show characteristic fracture patterns. A smooth beach mark appearance on the fracture face, indicating slow crack growth, distinct from the jagged overload fracture pattern of pieces that were torn apart in secondary breakup. Weeks into the recovery operation, investigators at the dock in Magong, Penghu, examining the recovered debris section by section, found what they were looking for. Item 640, a large section of fuselage skin and supporting structure from the lower right aft fuselage, which included the doubler plate from the 1980 repair, showed the signature of a fatigue-initiated failure along the edge of the doubler. When the investigators removed the doubler plate from item 640, they found the damage from the 1980 tail strike still present in the underlying skin. There were hundreds of long scratches running fore to aft, sanding marks where a mechanic had attempted to blend them over. Where the scratches lay outside the outermost row of rivets, investigators found the fatigue cracks. A primary crack 15.1 inches long and multiple smaller cracks extending from the scratch damage. The fretting marks on the fang surface of the doubler confirmed the crack had been present and growing for an extended period of time, flexing against the underside of the plate through hundreds and thousands of pressurization cycles before the final failure. The crash was investigated by Taiwan's Aviation Safety Council, or ASC. The FAA participated and Boeing participated as well. The ASC's final report identified the probable cause as structural failure of a 22-year-old tail strike repair located on the aft lower lobe of the fuselage. The skin scratches associated with the tail strike event had not been removed prior to installation of the permanent repair doubler. Over time and airplane cycling, multi-side cracking progressed on the scratches, ultimately leading to catastrophic failure of the airframe. The ASC primarily identified 2 direct failures in the 1980 repair. First was the damaged skin was not removed before the doubler was installed. Boeing's SRM required the damaged skin either be replaced or trimmed to clean undamaged material before a doubler was applied. Leaving scratch damage in place beneath the doubler provided no protection against the propagation of fatigue cracks from those scratches. Second, the doubler plate was too small. It did not extend sufficiently beyond the damage boundary to contain the damaged area within the protective coverage of the rivets. scratches lay at and beyond the outer rivet row, outside the zone the doubler were designed to protect. The investigation also found that no subsequent maintenance inspection over 22 years had detected either the inadequate repair or the developing fatigue cracks beneath the doubler. The doubler's presence over the damaged area concealed the scratches from visual inspection. The fretting marks on the doubler's interior surface, which would have indicated crack growth had the doubler been removed for inspection, were not visible from the outside. The residual strength analysis conducted by the ASC estimated that by the time of the accident, the continuous crack in the skin was at least 71 inches long, well beyond the 58-inch threshold at which the fuselage structure would lose the ability to sustain normal pressurization loads. The ASC also noted a direct parallel with Japan Airlines Flight 123, which I already made a video about, which you can check down in the description down below, which had crashed on August 12, 1985, killing 520 people after its rear pressure bulkhead failed, the result of an improperly installed repair doubler following a tail strike in 1978. In both accidents, a doubler plate had been installed without adequate coverage of the damaged area, and in both cases, the underlying damage had been hidden from inspection for years before catastrophic failure. China Airlines disputed portions of the ASC's findings, stating that the investigators had not recovered all the sections of the aircrafts that would be needed to definitively prove the repair's role in the failure. The ASC maintained its conclusions on the basis of the evidence recovered, including Item 640, the fretting analysis, and the residual strength calculations. The crash accelerated broader regulatory attention to aging aircraft programs, the systematic process by which carriers assess and manage fatigue damage in older airframes. The Flight 611 accident demonstrated that a structural deficiency could remain hidden beneath a repair that had been logged as conforming for over 2 decades, accumulating damage through thousands of pressurization cycles with no indication visible during routine maintenance. China Airlines Flight 611 remains one of the deadliest aircrafts in Taiwan's history. It is a reminder that in aviation, no compromises can ever be made in safety. Thank you all so much for watching this video. If you want to see more flight videos or more disaster event videos, be sure to subscribe and check out my playlist down below. Also, if you have any ideas for future videos, be sure to let me know in the comment section down below. And like always,